everyone, and the final session of this season's Citing Vulnerability series. As promised, this is our second scientist on the team this time after Professor M.N.V. Prasad of the Life Sciences speaking about the environment and climate change. We have today Dhiraj Pradhananga, who is a glaciologist by training and occupies the UNESCO chair in mountain water sustainability in Nepal and is also a faculty at Tribhuvan University. I met Dhiraj at the UNESCO chairs event earlier this year, and he told me he's a glaciologist. So, as revenge for not knowing a thing about what he does, I gave him a poem to read, 13 Ways of Looking at a Glacier. That's how we understood a little bit about each other's work. So I'm delighted to have Dhiraj here. And welcome, Dhiraj, and thank you for agreeing. I know you had a hectic time traveling here and there in the last few months. And congratulations on your new massive international collaborative project. Welcome to everyone else. And I'll hand you over to Atul for a more formal welcome. Thank you and welcome.
Thank you, sir, and welcome, Dr. Pradhananga. And if I may formally introduce you to the audience, Dr. Dhiraj Pradhananga is Associate Professor of Hydrometeorology at Tribhuvan University in Nepal. He started his professional career as a meteorologist at the Department of Hydrology and Meteorology in the Government of Nepal, 1995 to 98. He received his master's degrees from Tribhuvan University in Meteorology and the University of Melbourne, Australia, in environment, and a PhD degree from the University of Saskatchewan in Canada in glacier hydrology. He also did postgraduate diplomas in hydrology from IIT Roorkee in India and the management of the environment at the Maastricht School of Management in the Netherlands. His work interests are in making useful information usable in water, weather, climate, and the environment sectors. He is the president of two NGOs, namely the Small Earth Nepal (SEN) and the Center for Research for Environment, Energy and Water (CREW). He is also the UNESCO Chair in Mountain Water Sustainability at Tribhuvan University. With this, may I hand it over to Professor Pradhananga. Welcome and over to you.
Thank you very much, for a nice introduction and for this special opportunity to share some of my thoughts. Let me share my slide and then I'll proceed. And I'm glad that I can speak with you and interact with you. And special thanks to Pramod Nair and Anna Kurian from the UNESCO chair in vulnerability studies from University of Hyderabad. So today, as provided by Pramod, I have a little bit more than half an hour, about 40 minutes. I'll be talking a little bit about cryospheric sciences. It's a not very complicated term. Just if water is in a frozen state, then we call it cryosphere, either in terms of snow, ice, or permafrost, or any form of frozen water. And then how it impacts the changes impacts in headwater hydrology in the Himalayas, because we are impacted and influenced by the changes in the Himalayas. So with that brief introduction, let me go to the next slide. So this is how I would like to start, because I have, extracted this sharing from Twitter last year. So in social media, like Twitter, LinkedIn, Facebook, and everywhere, whenever there are some sharing of climate, we see this kind of graphs. For example, this one shows the red line is for 2023 and the yellow is for 2022, and similarly blue is 2016. So it says that there are increase in temperature every year, and every year is a record bit from the past years. So this is what we see in social media, presenting the warming climate. But my presentation today, or just a very simple discussion today, is related with what does it mean to the Himalayas or cryosphere, where water is in frozen state, and when precipitation falls, either in the forms of snow or the mixture of snow and rain, and these water stays in the cold region in the form of frozen fern or glacier, or frozen soils are there, and then permafrost are there. So this is what I'm trying to discuss today. And whenever we talk about climate change and we consider high mountains and glacier, this is one of the very popular uh, photograph series from 1978. If you can see my cursor, from 1978 to 2004, the researchers named it as X010 glacier. And if we see these photographs, we clearly see that the glacier extent is retreating, and every year, every decade, we see some reduction in its area. And in up to 2004, we can see that now the glacier retreated lot. I mean, it's melted down, and there is no proper balance, or health of a glacier is not maintained. So this is a very popular diagram to convince policymakers and other leaders, to convince them that there is an impact of global warming on glaciers. And definitely you may want to see what happens after 2004. So I'd like to show a few photographs from my colleague, Region Dr. Kayester. He took in same spot 2008, and we see that the retreat is even more. And then last year in 2023, glacier is almost gone. So this is the reflection that we see from the figures or photos, from, if we see the time series photographs from different time. And this is one of the examples. And the another thing is, with the retreat of glaciers, the lakes, glacier lakes are expanding, or new glacier lakes are forming. So one of the glacier lakes on the left, how it expanded from 1953 to 1999, almost area increased from zero point 0.3 square kilometer to 0.75 square kilometer. It's the Inza Glacier Lake. And similarly, on the right panel, it is of Chorolpa Glacier Lake, which is one of the largest glacier lakes in the Himalayas. And also we see that how the glacier lakes, size of the glacier lakes are increasing each year, and it has shown till 2002. And with those increment, and we consider these lakes with the size and volume of water that are retained by the moraine, they are called as a potentially dangerous lakes, because they have a potential of breaching and impacting downstream if they got breached. So what the government of Nepal, Department of Hydrology and Meteorology, did that they lowered these two potentially dangerous glacier lakes, Chorolpa and Imja Lake. In 2016, Imja Glacier Lake was lowered by 3.4 meter, and in the case of Chorolpa, it was lowered by 3 meter in 2000. So this is one of the mitigation measures that government of Nepal did to prevent from potentially uh, breaching of those glacier lakes. But when we are talking about this effort, but we still have news coming from India, Nepal, Bhutan, China, and Pakistan, that there are a lot of incidents in the recent years of floods. Like we can consider Sikkim's flood, and again Ladakh in India. Similarly, in a central Nepal is Mustang, Kagbin in Mustang. These are the floods because of changes in high mountain water storage, or we say cryosphere induced disasters. So this is not stopped. And we also get news from every almost every year. We have kind of such cascading hazards started with some of the changes in high mountains, and they are not only taking lives and impacting infrastructures, roads, swept away villages, hydropowers, and many things. So these are the consequences we are now experiencing with changes in high mountain water system. With that, we know that due to the inaccessibility or limited resources, there are lack of hydroclimatic studies in high mountains and especially in the Himalayas, where there are dense distribution of glaciers and glacier lakes. And as per the research and studies, we know that there are increasing rates of air temperature, and especially it is higher increase in air temperature than compared to the global averages. And also the changes in precipitation, but they are very heterogeneous, and there are different rates of uh, temperature or warming climate. But the problem is that there are very less study, and especially snow related studies are limited in the case of the Himalayas. So based on that, I'd like to uh, discuss today's during today's discussion three major points. The first one is how important the change in precipitation, especially precipitation phase, compared to the change in glaciers. But I consider that glacier is glamorous, and whenever we talk about warming climate in the Himalayas or in the cold regions, we consider retreat in glaciers, or like I showed some of the examples from how glacier lakes are expanding and how they are posing challenges to the downstream communities. And so, with that, I would like to discuss whether the changes in precipitation is also important in high Himalayas. So here, if we see two um, photographs are taken at different times, so one is in 1988 and the another one is 2015, we see that ice and snow extent are reduced. So what does that mean? How it is being reflected. So I don't want to go more technical part, but definitely I would like to brought into our attention that changes are there, and we need to do some research, and especially we need to understand these changes using physically based models that are based on physics. How the changing in climate and changing in these landscapes are impacting hydrology of water towers or headwaters. And the third one, I really want to connect that with these changes and impacts that we are facing at present time needs to be addressed by collaboration and networking between researchers, policymakers, as well as communities. So with these three things, uh, to address them, I would like to provide brief introduction or brief description of two recent events last month and a couple of months before. There were two incidences that happened in Nepal, and they are studied by two of my students. Manavi Chaulagai, who is my undergraduate student, she was at Birendra Lake area when the event happened, and another one by my PhD student, Dinker Kaist, related with one Bluff Glacier Lake outburst flood. So I'll briefly go through these things and share with you. So let me start with my first research that I started in 2008 and 9. So what we did is we visited several parts in Nepal, and we talked with people. We use a vulnerability risk assessment, and we talked with community, and we realized that they have experienced changes in climate, especially increase in temperature and changes in rainfall or precipitation patterns. And they reported us that the rainfall, precipitation can fall in a form of rain or water, or in a cold region if the temperature is low, and the precipitation falls in the form of snow. So we call it snowfall. So this is what they have noticed, and they reported us that there are changes in precipitation patterns as well as a precipitation phase. So instead of snow, more rain is happening. And they were reporting that the amount of snow that covered their areas are reducing, and in the higher mountains where snow used to be throughout the year is not anymore. And also they have noticed that they have reported us that spring waters are drying, and these are the results of less snow in upper catchments. And similarly, they were saying that there are several impacts to the agriculture, especially winter crops are failing. So that was the report that we got in 2009. And this year, when I visited one of the those study sites, it is western Nepal in mountain. The name is Jumla. They reported that in 2009, they said that they used to get snow 2 to 3 feet, and in before that they used to be 3 to 4 feet. But now nothing. So last year in 2023 in winter they didn't receive any snow. So what this is showing us that they have experienced the changes in precipitation, especially not the total precipitation amount or total measurement, but the changes in a precipitation phase. So instead of snow, more precipitation are occurring in rain. So this is what they have experienced. So here are some of the photographs that I have taken in 2009. It is showing that they used to have houses with mud roof, but now these houses are not suitable to the location because of more rain compared to the if you compare it the snow and rain. So this is some of the examples, and how they are the heavy precipitation as well as flood are impacting. This is a they used to have a wooden bridge over here, and that was swept away due to the flood. And thus after that, my colleagues in the small earth Nepal, they try to see whether those perception how people reported us about changes in snow cover. And they try to see using a remote sensing satellite images. And this is I'm not trying to give you uh, much technical details, but what we see here is that this is from 1990. And if we change the image from 1990 to 2018, we see that there are reduction in snow cover areas or snow and ice cover areas. So definitely, this is just one example that how we can uh, absorb the changes in a high mountain. So this is a 1990 from the Landsat images, and this is 2018. So this shows that there are changes in snow and ice cover areas in a high mountain areas. With that, I'd like to now give discuss on two recent events that happened this year in Nepal Himalayas. The first one is avalanche Hajar that occurred in April 2024. There is a lake named Birendra Lake, and what happened was there was avalanche from the mountain nearby, and it uh, the avalanche of snow and ice, the mixture of snow and ice fell into the water, the lake, Glacier Lake. And what happened is like it spilled. So it spilled, and there was a flood occurred downstream. So this is one of the cases that I really want to uh, discuss over here. That happened on April 21st, and my student Manavi was hiking around the area, and then we communicated and see went to the lake area and wanted to see, what happened. And especially, this was not reported by any government agencies, or there was not any early warning system, but it was reported by the locals, the communities. And then hydrologists looked at the stage downstream, and they found that at the Kap station, within 20 minutes of that event, 69 centimeter, almost three-fourth of meter of rise in water level was observed. So this is one of the example that happened recently, and this is before and after they went here. Manavi is here. So this is in 2023, around the same time in April 9th, the how lake looks like, and this is Mount Manaslu. And then after the avalanche, we can see the ice is floating around the lake. So this is one of the examples, how the disasters or such kind of floods starts. And this is more photos here, aerial photos, how debris of the ice avalanches are floating in the lake. And this is Mount Manaslu Peak, from where the avalanches started. But my focus over here, or our focus was, whether such kind of events how people are considering those kind of event. And especially this is her exercise to see, whether she can generate uh, hazard or hazard map based on the slope and other factors. And she has developed a map showing low susceptibility, moderate, and high. And her part of the study is also the community perception, how the people living around the area are considering such kind of events. And she reported that they are not much aware or worried about such events. And definitely such kind of events may occur in the future and can cause um, higher impacts and impact on people's lives, as well as properties and infrastructures. So this is one of the examples. They are not prepared for such kind of disasters. And the second one is the Bluff Glacier Lake outburst flood that happened in the Everest region. It is popularly known as a Tommy Bluff, and it was of great international attention because there is a such kind of events are highlighted when there are related with the regions like Everest, because there is one of the very high attraction for tourists. And this is the Tami village after the Bluff. So it swept away um, several houses, one school, one health post, and also impacted hydropower downstream. So this is not only at the upstream but also the downstream. Because of the high flow, now the settlements are in a vulnerable situation, because there are cascading impacts of such event. And if we want to know a little bit more about the event, then we need to consider that it is not a new incident that happened, but there was in 1985 the adjacent Dikcho Lake was burst, and the Gulf was massive, and it impacted several villages downstream, also hydropowers and other infrastructures. But these were bigger lakes, and but nowadays even the smaller lakes are posing threats to the glacier lake outburst floods. So this is how it happens. There are five lakes, and avalanche or some kind of slides or rock slides. The final study is yet to come. But what happened was the upper lake, there was a splash similar to the Birender Lake, and then the water uh, uh, flowed to the lake downstream, and then the moraine of the lower lake breached, and then flood occurred. So this is one of the example, how the changes in a cryosphere or high mountain regions are impacting and causing damages downstream. So this is the lake number two, lower lake, how it reduced the size after the breach. So this shows before the Gulf event, the lake size was this much, and then after the Gulf event, and this is the size of the lake. Dinker Kaister, he also did some kind of precipitation and temperature analysis, and he realized that there was a sudden rise from almost 12 uh, and 13 degree to 16 degree within a week time. So there are some indication that there are changes in abrupt weather in the vicinity areas. So that reflects that it has some linkages, but definitely it is still under study, and we are waiting for final research outputs to come. But one thing that I really want to point out here is this event also was noticed first by the communities, and they shared using social media, and only the government officials and other people who are responsible for disasters, risk reduction, or disaster management, they were informed. And after uh, the locals informed about the event, then the government of Nepal, Department of Hydrology and Meteorology, sent mass SMS to the downstream, alerting them about the flood. And definitely the uh, messages reached downstream people before almost a half an hour or 1 hour before the peak flood. So this is how the community is uh, alerting or informing about such events, but we still do not have any kind of early warning system activated in such events. With that, what I really want to highlight is that we need to do research on such kind of changes if to save our lives and properties and biodiversity, because these are there are changes in the precipitation patterns, and especially impacting people's and their livelihoods. And definitely we are working using a cold region hydrological model, one of the glacier hydrological models. I haven't kept more slides over here, but if interests are there, then I'm very much interested to discuss more, how we can use hydrological models and apply them to study high mountain cryospheric changes. With that, my few final slides are coming up, but my simple question is whether simple thoughts or action could be influential, or we can um, have some impacts to address those changes in the Himalayas. So, uh, as introduce one of our chair program, UNESCO chair on in mountain water sustainability, has four universities: University of Calgary, University of Saskatchewan, University of Chile, and Tribhuvan University. So this is a very unique chair program with four universities, three countries, and six chairholders. What we are trying to do with this chair is to address these issues that is happening with warming climate in high mountains, especially related to it water crisis and disasters due to the excess water, and to develop collaboration and partnership among broader research groups, not only within the countries but um, beyond these three countries. And our attention or our focus is also to bridge the physical sciences to society and community needs, and through several approaches, including education, like trainings, research, capacity building, and networking. what we are planning for this year and next year are some of the training courses on the modeling, as well as how to include social research or social sciences into the physical science, and then apply these research into the real lives. And one of the approaches we apply is international network on alpine research catchment hydrology. uh, Pramod was saying about my travel. So I was attending in our annual meeting in China, and we discussed, how to proceed ahead. But this there are some other activities we have planned, and especially one of the key uh, part of our chair is a community-based participatory framework to address mountain water sustainability. And one of the achievement that we have obtained recently is the UNESCO shareholders contributed in the UN World Water Development Report that will be launched in 2025 during uh, World Water Day. And it this year it has focused on mountains and glaciers, and we have contributed chapter 2 and chapter 8. Chapter 2 is focused on the cryosphere and its impact on water, and chapter is focused on knowledge and capacity building. With that brief description, I really want to highlight that since there are concern of changes in water towers, especially changes due to the cryospheric alteration from global warming. There are some of the events or efforts globally. One of them is International Year of Glacier Preservation. So 2025 is announced as the International Year of Glacier Preservation. So this is an opportunity for us to learn about the glaciers and mm, make policymakers and also aware the community how they are changing. And since next year, March 21st, will be celebrated as a World Glacier Day, and it is similar to the World Water Day and World Meteorological Day. We have March 22 as a World Water Day, and March 23 as a World Meteorological Day. So the one additional day, March 21, would be World Glacier Day, and that would be celebrated every year beginning from next year. And one year is not enough for such activities, and especially when we consider research and changing the people's thought and awareness. So we have now UN decade of actions for cryospheric sciences for from 2025 to 2020 to 2034. With that, I have two couple of more slides. I really want to use this slides in my presentations, because this is how we are impacting our climate, especially. So this is the climate, very general diagram of climate model, climate system, how it is presented for education, for research, and for presentations. But there is something missing, and we know that there is a one major component that we need to add in this climate system, and that is our society, or we can say that now the human beings or societies are part of the climate system that we have, and this is how we are influencing the climate system, and definitely we are also influencing the hydrological cycle that happens over the planet. And with that, my this is the slide that I borrowed from Professor Mickey Glantz, who is working with me since last 3 decades, and he his slide is a little bit innovative in a sense that sometimes he takes photographs or some clips from the social media and makes his uh, argument on that. But this is what he tries to convey, that there is not any planet B, but we do have several plans B to cope with climate change. And with that, I really want to conclude my today's brief presentation, and especially the changes in high mountains and how it is uh, impacting or threatening the whole water tower. Especially, it has consequences on reduction of water availability, flooding risks, and then productivity in agriculture, especially winter crops, and also because of either the variability in a stream flow uh, or the floods like Gulf, or even the cascading effects, and the furthermore landslide dammed outburst floods that are impacting hydropower generations as well. And the another important part that is there is that there is not adequate meteorological and hydrological information for the local communities, and so that as a result they are losing their lives and properties. And similarly, we need to have a, timely but accurate forecast for such events. And there are some new tools, satellite missions are there, so we should be applying them. With that, I really want to conclude today's my brief presentation and open for discussion. And final one key message is that I want to leave is uh, we need to have a collaboration and networking for research capacity building and linking science policy society, because science needs to be for uh, society and for nature. With that, once again, thank you for joining today's conversation, and thanks Pramod and Anna for having me and the whole team. And thank you. And I think we can open the discussion.
Thank you so much, Dr. Pradhananga. And we'll now have questions and comments from the audience. Roy has a question. Roy, please go ahead.
First of all, thank you, Dr. Pradhananga. It was indeed an enlightening presentation. My question was in regard to, the extraction of ice cores, which is a very main concern of science. The extraction of ice cores from glaciers. Ice cores are, you doubtlessly know, they are like sticks. They are like cross sections of glaciers, and they have annual layers of ice
Mhm.
which act as climate records, reliable climate records for a large number of years, and so are very valuable for science. But when it comes to the extraction, Western science says that before every glacier in the world melts, it should we should be able to extract at least one ice core or two from these glaciers. And the implication here is that, at least one feels that there is an attempt to place the blame on the local community for a phenomenon like global warming, which is unfair because, emissions all contribute to the melting of glaciers, and the majority of emissions comes from the Western countries. So even though the local, so it's not fair to blame the local community alone. And as you had pointed out, in many cases, the local community is entirely unaware of the disasters like ice dams, breaking and floods and things like that. So, I wanted to ask whether or not it was unfair to blame the local community or that country alone for, the glaciers melting and large climatic phenomena of which they have no control or awareness. That was my question.
Okay, thank you, Roy, for your comments and some backgrounds related with ice core uh, examination, along with whom to blame for these glacier retreat. So today's my, in fact, presentation. I was trying to convey that it's not only the changes in glacier, but changes in precipitation phase is also important because of global warming. Definitely, the warming climate that is, which I said shared in first few slides, that it's the rates of increase in climate or the temperature in high mountains is higher than the uh, global average, saying that the impacts are more in high mountains, and definitely we can't blame the locals because the climate science is clear now that it is due to the greenhouse gases that our advancement or our lifestyle, that we use fossil fuels and emits greenhouse gases which are causing the warming climate or the climate change, and it is impacting or affecting the retreat or the health of glaciers, so that it couldn't maintain its annual mass balance. So why is that? So there are a couple of things. The first, as I said, if the precipitation falls in the form of rain instead of snow, there are multiple impacts. The first thing is snow cover is like a blanket to the ice, so that it's a we call it albedo, because we receive radiation from sun, and if it is covered by snow, its albedo is very high, zero point 0.8, 0.9, and then most of the radiation reflected. But if it is in the form of rain, then there's no blanket, so it's exposed, and the albedo is reduced, and more radiation is absorbed, and melting is faster in that case. And definitely if precipitation is in the form of rain, it has also its energy that transmits to the um, ice or snow, underlying snow, and the rate of melting is faster. And not only that, if we do not have snow accumulation, then we do not have a glacier formation, because glacier is formed from snow, not from the rain or frozen water, but it's a compact nature of snow. If you have snow accumulated for several years, and it turns into fun and then ice. So this is the process that we have to maintain um glacier. But my point here is definitely your valid reason is we can't blame the locals for the retreat of glacier. But what I'm trying to bring here attention is that the changes in these precipitation patterns not only causing the glacier retreat faster, but also livelihoods and biodiversity. It is causing some kind of increasing disaster, as well as livelihoods in the high mountains, especially affecting agriculture products. So this is what I'm trying to convey the message. But I agree with you that we can't blame local people who are not responsible for these cases.
Thank
Thank
you,
you. Thank
Dr.
you.
Pradhan. Thank you, Dr. Pradhan.
Hello, can you hear me?
Yes. Yes.
Yes, I'm Shubha from Pune, and this is really an excellent lecture. And we came to know many things from you, sir. I have one question that you have given one main message that collaboration and networking for research capacity building. So, how it could be linked to society? How can we give water conservation message to all? Because it has to go to the society. You are doing excellent work.
Yes. Thank you. Thank you.
Shubhada.
Nagarka. Yes, Suvada, for your question. And this is the main drive for, in fact, my activities or the recent projects that I'm leading in the region. And before this presentation, I was talking with Pramod that recently we have got one Asia Pacific Network for Global Change Research project for the region, South Asia and China. We are looking at changes in precipitation patterns and how they are posing threats to water resources and to food production, food security. And in this project, we are not only looking at the science, what are the changes, but we are also the major component of the project is to communicate or to engage the community. So we have selected study sites in all the countries, participating countries in India, Bangladesh, Nepal, Bhutan, and Pakistan, and China as well. And what we are trying to do is we are not only just researching about the climate science, but we are also trying to understand how they are adapting and how they are observing the changes and what they can do if such changes are happening. I showed some examples from one of the districts in Nepal, Jumla. Now the houses, they used to have mud roof, but now tin roofs are they are using tin roofs for their houses. So because of the changes in the precipitation patterns over there is not anymore suitable from the past. Definitely the modern life also encourages them to have different types of houses, but one of the reasons was that. And then the second thing would be the crop pattern that they are choosing. So they have now changed the seeds and the species and also the crop calendar. So that is how we are trying to implement whatever the science we understand. We do research in the areas and link with the community. And the UNESCO chair in mountain water sustainability, its a main focus is to bridge the two different things, especially respecting the indigenous rights and understanding the local knowledge and indigenous knowledge, and how that can be integrated with the modern physical science. So this is what, in fact, we are trying. And my thought is that if there are information or data related with the water, climate, or weather, and if it is not usable, then it's not the science. I think that those needs to be usable. They could be useful, but if we do not use them, they are not applicable for our life and our nature. So this is the drive that I'm having with my team in my organization and with the water chair as well. Thank you,
Thank you.
Suvada. I
Thank you.
hope I
Thank you.
answered your question.
Yeah, yeah, yeah. And one small question, whether you said it's a huge data you are creating and generating, analyzing.
Mhm.
So do you maintain it on the website, or is it open to the public, or how you are managing that huge data?
Yes, that's excellent question. In fact, I my visit to China was successful in that case also, because they have a data center which is hosting the regional data that we will be generating. And uh, from APN, the policy and also the lead organization, the Small Earth Nepal, we have a policy that the data and the science should be open and it should be accessible to all the interested users, researchers. So this will be open. And in the past projects also, we have maintained those open data policy, and definitely UNESCO has also open data policy. So these will be available through the already existing open data sources, and we are also trying to link that with other global data centers so that researchers and people can access those generated data sets.
Thank you, sir. Thanks a lot. Yeah.
Thank you for your question. I think we still have 14 minutes left.
Are there any
If there
more
is,
questions? Yes, please, ma'am, please.
do you have any course on this that people will understand about these issues uh, at
Yes,
to
in fact, the project that I mentioned is a APN project that we are launching from this year. This is for 2 years, and we have five participating South Asia, Asian countries, and China, and along with expert teams from USA and Japan. We will be organizing winter course. One of the component of the project is that we provide trainings to the early career professionals. That includes undergraduate and graduate students, as well as early career researchers, ECR and ECP. So that will be announced, and we kept on doing that since 2001, when we established the Small Earth Nepal. And sometimes the trainings are national, focused in Nepal only. But the training that I have mentioned is regional one. And with the UNESCO chair in mountain water sustainability, we are also planning to have global training that will be online, and we are trying to not only to train physically based glacier hydrological models, but also how societal or social science could be, or the issues of equity and indigenous rights could be integrated in water management system. So that we are planning to organize, and we will be announcing them as well.
Wonderful. Thank you so much. Thanks.
Thank you.
Are there any more questions, comments, or responses to Dr. Pradhananga's talks? If there are no more questions, we could move on to a formal vote of thanks by Professor Anna Kurian, who is a faculty fellow at the University Chair in Vulnerability Studies here at the University of Hyderabad.
Thank you. Thank you, Atul. And I apologize in advance for the noise that will be here in the background. But also, thank you very much, Dr. Pradhananga, for the talk which made science accessible, especially for somebody like me. I gave up science, studying science in class 8 back in the day. So for me to understand anything at all related to science, climate change is difficult when it is a scientific angle. I'm only used to fiction. So listening to you, however, was a revelation, because you made it, the problem, of course, is urgent. We all recognize that, but you also showed us what underpins the problem and how it affects the lives of the people. Thank you so much for the work that you put in to make your work and your knowledge accessible to people like us, people like me, to be precise. Thank you also, of course, to all of you who are present here today. I would like to give a special call out to Professor Bhim Singh, who is here from the Hindi department at the university. It's lovely to have him here, and he has an interest in work coming out of Tibet and the neighboring areas. So it's also part of the reason why he is here today. We also thank, of course, our stalwarts from the reading room at the department, but also Roy, who's always here, the first one to put his hand up, first one to ask a question. Roy is a part of the UNESCO chair like no other. So thank you so much to everybody who's present here. But most of all, thanks to Dr. Pradhananga and Pramod, our two UNESCO chairs at this meeting. It's one of those few events where we have two UNESCO chairs collaborating on an event. So thank you so much to all of you once again.
Thank you, Dhiraj, for finding
Thank
the
you.
time. Yes, and we look forward to seeing more of your work, as you said in your response to Shubha's question. Thank you, and thanks all of you.
Yeah, thank you very much for having me, and thank you for the interactions. It's my
Great, thank you.
pleasure to have you. Yeah. Thank you.